seeing a sinusoidal problem with cosine, a positive cosine. First of all, cosine is graphed like this, starts from the top. And as it is a positive cosine, starts from the top. If it was a negative cosine, it would have started from the bottom, but it's not. So, the problem that we're going to be seeing today is a predator-prey model in which the predator population is modeled by this function. And 900 is the amplitude, it is the cosine function, 2t, which t is measured in years, time, and 8,000 is y, and it is the starting point. So, the period, the formula for the period is 2 pi over k. So, in this case, k is 2, so the period is equal to pi.
Now, I am going to explain the maximum amplitude of the wave. The amplitude refers to the maximum amount of displacement in a function. For example, in this function, as you can see, first we need to identify the values. Here, this number, 900, means the amplitude, and the starting point in the y-axis, in this case, 8,000. Now, to graph the amplitude of the wave, you need to see the graph and locate the starting point, in this case, 8,000, and then increase the graph upwards and downwards using the value of the amplitude, in this case 900. In this case, the amplitude was already put into the function, and the values that it's going to give is 8,900 and 7,100. And now I'm going to explain simple harmonic motion. Simple harmonic motion is any motion in which a restoring force is applied that is proportional to the displacement and in the opposite direction of that displacement. Or in other words, the more you pull a graph towards one way, the more it will return to its other position. But for example, in this graph, if we have a restoring force over here, the graph will be pulled to this side, similar like a spring. But for example, if our restoring force is over here, then the graph will shrink, and also the period will be smaller.
So after we explain what's the amplitude and the starting point, we know that the y-axis is measured in predator population, and it's a positive function, so it starts in the upward amplitude, which is 8,900. The first question asks the maximum population, so that's why the maximum population is 8,900 predators. For P, we already sketched the graph. So after we get the period, there's subdivisions in the period that it's divided into 4. So we have P quarters. That's why each cosine function, it's P quarters, and the total of the period, it's P. So T is measured in years, that's why P years is for each function.
I'm going to explain more profoundly the length between successive periods. In this case, this sinusoidal function is a periodic function. M refers of how often from its middle point it makes a complete cycle. In this case, the median point is 8,000 and is vibrating, so it's periodic, and its highest point is not 8,900 and its lowest point is 7,100. And this, from this to here, is only one period, because it's how it goes downwards from its middle point, and then it goes upwards from its middle point. So the period is from here to P. The frequency of a wave refers to how often the medium vibrates from its median point. When a wave passes through the medium. The objective of this project was to learn how sinusoidal functions are applied in the real life. In this case, this problem was about the predator population. We learned that y, being the dependent variable, in this case, the highest point was the maximum population, 8,900. And also, we learned that x, being the independent variable, as you can see here, p is 1 period and goes from p to p, and we divide it into 4. So this was excellent project because we learned more about cosine function in the real life, y and x. Thank you.